Welcome to the explainer. So you've heard this term everywhere, right? Machine learning. But what is it really? Well, today we're going to pull back the curtain, demystify it from the ground up, and show you how it's already running our modern world. Let's jump in.
I mean, just think about it for a second. How does your email inbox stay so clean from all that junk? Or how does your streaming app recommend a movie that feels like it was picked out just for you? That's not magic, not by a long shot. It's machine learning, and it's working quietly in the background of your life every single day.
So what's the big difference here? Well, in the old days of programming, a human had to write every single rule. For a spam filter, you'd write, if an email says buy now, it's spam. Simple enough. But then the spammers change it to purchase today. So you write another rule, and another. It's a game of whack-a-mole you can never win. Machine learning just flips the whole script. Instead of feeding a computer rules, we feed it data. Thousands and thousands of emails, both good and bad. And we tell it, you figure it out. The computer's job completely changes from just following rules to actually finding the patterns for itself.
And that pattern finder we keep talking about? Well, it has a name. It's the absolute heart of machine learning. We call it a model.
This is the star of our show, right here. The best way to think of a model is like a tiny digital brain that we're building from scratch. It starts off knowing absolutely nothing, but as we feed it data, a special algorithm trains it, kind of like shaping its neurons until it gets better and better at whatever we ask it to do. It's the student in our classroom.
So how does this student of ours actually learn? It's not just one and done. It's a powerful and honestly pretty simple three-step loop that it just repeats thousands, sometimes millions of times. This whole learning thing is just a constant feedback cycle. First, the model takes a guess. It makes a prediction. Then it checks its work. A little piece of math called an error function tells it exactly how far off that guess was. And this is the magic part. It uses that score to tweak its own internal wiring. That's called optimization, so that its next guess is just a little bit closer to the right answer. Predict, check, adjust. Over and over and over. That's how it gets smarter.
You know, just like students in a classroom, machine learning models don't all learn the same way. There are really two main paths they can take, and it all depends on the kind of textbooks or data we give them to study.
The difference really boils down to one simple thing. Does it have an answer key? With supervised learning, the data we give it is all neatly labeled. It's like studying for a test where every single practice question comes with the correct answer printed right below it. Easy. But with unsupervised learning, we rip that answer key away. We just dump a mountain of raw data in front of it and say, find something interesting, find the patterns. Let's make this real. A classic supervised learning example is predicting house prices. We feed a model tons of data about houses, square footage, number of bedrooms, location, you name it. But here's the crucial part. For every single house, we also tell the model what it actually sold for. That final sale price, that's the label. That's the answer key it learns from.
And for unsupervised, imagine a big retail company. They have tons of data on what people buy. They can feed all that purchase history to a model, but with no labels, no big spenders or coupon clippers. The model's job is just to find natural groups on its own. And it might discover things the company never knew, like a group of people who only buy organic stuff on weekends. It finds patterns they weren't even looking for.
Okay, so our model has been studying hard, it's been going through its learning loop. But how do we know if it actually learned the material? Or if it just got really good at memorizing the study guide? This is where we have to separate the classroom from the real world. This might be the single most important rule in all of machine learning. You just can't test a student on the exact same questions they studied with. That doesn't prove anything. To really know if a model is smart, you have to hit it with questions, with data it has never, ever seen before. So here's how we do it. We take our whole data set and we split it. The big piece, usually around 80%, is the training data. That's the textbook. That's what our model gets to study. The other 20%, we lock it away in a vault. That's the test data. Only after the model is completely done training do we unlock the vault and give it the final exam. Its score on this test is what tells us how it'll actually do out in the wild. And this brings us to the biggest trap you can fall into, overfitting. This is what happens when the model doesn't just learn the patterns,
It literally memorizes the training data, warts and all, including all the random noise and details that don't matter. It's the student who can recite the textbook word for word, but if you ask them a question that's phrased just a little differently, they completely freeze. An overfit model looks like a genius on its practice questions, but totally bombs the final exam.
All right, we've covered the big ideas, the grand strategy. You ready to get our hands a little dirty? Let's pop the hood and look at a couple of the actual tools that make this whole thing work. You've probably heard of this one, linear regression. It sounds fancy, but it's a real workhorse. All it's really trying to do is draw the best possible straight line through a cloud of data points. That's it. And that makes it perfect for predicting a number that can be anywhere on a scale, like forecasting next quarter's sales, or, yep, going back to our example, estimating the price of a house. So our model is built, it's making predictions. Great, but are they any good? I mean, how do we grade its performance, especially for something like our spam filter? Just saying it's 85% accurate doesn't really tell you the whole story. We need to know what kinds of mistakes it's making.
And this is the model's report card. True positives and true negatives, those are the easy ones. It got the answer right, A+, but the errors are what we really care about. A false positive? That's when a good email gets sent to spam. You could miss something important. A false negative? That's when a junk email gets into your inbox. Annoying, but probably less dangerous. This simple chart lets us see not just if the model is wrong, but how it's wrong. And that's incredibly important.
And that brings us right back to where we started. We went from a simple spam filter all the way through models, learning loops, and report cards. As you can see, machine learning isn't some kind of dark art. It's a systematic, powerful process for finding patterns in the world. It is, without a doubt, one of the most powerful tools we've ever created. So the only question left, and it's the most important one, is what problems are we going to solve with it next? Thanks for joining this explainer.